Hello, everyone. Hope you're doing well. I just want to make another video to finish up the statistical analysis folder. I did the linear and logistic regression video, and I realized I missed out on a couple more simple and maybe applicable tests that you might be using for statistical analysis, and those are the t-test and ANOVA. And to be brief and give a little overview of the t-test and ANOVA. These tests allow you to see um, if the average value you have for a certain outcome that you're interested in, so let's say blood pressure, is different amongst let's say treatment groups or different categorical level variables that you're interested in, like let's say gender or age that was made into categorical variables. So t-test allows you to do it when there's two groups, and then when there's more than two levels of your study, then you would use an ANOVA just to see if there's a difference. So like let's say you had three treatment level groups and you want to see if there's a difference between all three, but you don't know which one is different, you use an ANOVA. And I'll just go through what the code is. And to start off, I'm going to just borrow a lot of code from the linear and logistic regression videos. So I'm not really going to use some of these packages that I'm loading in, but I'm just going to have them anyway. Like you wouldn't need ggplot in this case or Broom. You might need knitr or GT summary, but I think you really just need tidyverse. So let's run these. And like always, we'll use the body measures data set. And the reason why I'm including this code is because I wanted to get a categorical predictor that would have more than two levels, because that's when you need ANOVA. T-test, you can, as I said before, you only can use it if you have a two-level predictor. So I'll do the same outcome. So let's say, well, let's first load in the data. So we have we have all these body measurements, and let's say I wanted to just see if there's a difference in let's say bicep girth flex between male and female. So well, so I'll do that for a t-test, and then for a ANOVA I will make a three-leveled categorical variable based on age. And let's see if there's a difference in height, statistically significant difference in height. Or let's do weight. Height. Let's do height between these age levels. So and ANOVA just stands for analysis of variance. So the code for a t-test is pretty simple. We're going to just do we're just going to store it in an object. Okay, so bicep test, and we'll do so the function is just t-test, and then the first thing you're gonna do is the outcome, so or the y variable, which in this case is biceps, the bicep girth flex. bicep flex, girth flex. Don't know why I doubted myself. Flex. And then you do the squiggly line. And after you do that, that's when you write your the variable with the different levels, categorical variable. So this one will do I think it's coded as gender. And then we just say what the data is. So data is equal to body mass. So this is just showing just this function one more time, doing a t-test where we're comparing the mean bicep girth flexed measurement between the two levels of gender from the body measures data set. And we're going to put it into a storage object called biceps test. So run that. So now we have that. We can just enter that, make it like a list. So when you print it, it will give you the t-test, the degrees of freedom, and the p-value. And it actually gave you an interpretation of the the t-test or the t-statistic, sorry. And then it also gave you the sample estimates for bicep girth in male and females. So because it's statistically significant, that means that there is a difference in the mean. There's a statistically significant difference in the mean bicep girth between male and females in the study. Okay. So, and when you have this object, you can isolate certain things by using the money symbol, I believe. Like you can go like this, and then, or I guess you'd have to do, since it's a list, you have to state like which object you want, and it can, because it's a list of different things. You have a statistic, which is like the t statistic. Then you have um, sorry, you have the degrees of freedom, you have p-value, and you can isolate and just pull out whichever one you want if you wanted to print it out somewhere else. I believe this would give us the degrees of freedom. Oh, that's better. It wasn't working. Okay, there you go. Okay, so now you would just be able to print out any of these, which is nice. If you also wanted to assign it to another object, so you can use it for other data or graphing, anything like that. Okay, now we did that. I'll just quickly show how to run an ANOVA. It's very similar. It's just the function that we use is, I believe it's the AOV function. Um, so, um, but the actual structure of the function is identical or nearly identical to this. So let's do height over, and I'm not sure if we ran this, but just to make sure we did. Okay, so now height and over, we're gonna do AOV, that's the function. And now we do the same formula. So we do the continuous variable first that we want to see if there's a difference in the means. And then we write the more than 3 and 2 level categorical variable after the squiggly line. So we did height, and then we're doing age, hat, and the data is coming from the body mass or body measures, and then we run it. We can print it. Okay, so you can see that the um mm, huh. Let's see. I think we would have to then use let me just double check. Just gonna pause this real quick. Okay, so um I was able to find out that to see the actual test statistic that you want that like tells you about the p-value and whether there's an actual difference, you have to use the summary function because before when I just used height ANOVA, I just printed that result. You can see in the in the console, it gives you the sum of the squares, um, but it doesn't give you like the F statistic or the p-value. Um, so you would need to kind of look it up on your own. So the summary, if you use the summary function, it does that for you. So if you run that, then it gives you this nice table, gives you degrees of freedom and all of these things. So it gives you F value, and you see that the p-value based on the F statistic is greater than 0.05, which if that was your cutoff, that would mean there's not a significant difference between height in these age groups. And you could do the same thing um, with the biceps test, in terms of just like isolating the specific results that you want. Yeah, so that's it for these statistical tests. To give you a nice uh simple plot, and if you just have data where you're trying to compare a continuous variable across one group, then this would be perfect. So or two groups for the ANOVA and ANOVA grammar. So that's it. I hope you guys enjoyed this video, and see you in the next one.